Hello, I'm Carly McAvoy, talking about probability distributions. For a probability distribution, you need a random variable, that is a variable that has a single numerical value, determined by chance for each outcome of the procedure. And then you can create a probability distribution, and this is a description that gives the probability for each value of the random variable. So if we were rolling a dice, we would have these probability that would go with what's the probability of rolling 1, rolling 2, rolling 3. And in that case, they'd all be the same, right? But when you add them all up, they're going to equal 1, which is the requirement, one of the requirements for a probability distribution. The sum of all the probabilities has to equal 1, and every individual probability has to be 0 and 1 inclusive. So they could be 0 or 1, but they can't be any greater than that. Here's an example. You're taking a multiple choice test with 3 choices for each question. If there are 5 questions on the test and you guess on each question, what are the chances that you will get 0 correct, 1 correct, 2 correct, etc.? Now you're just randomly guessing, but there's 3 choices. So because there's 3 choices, you have a 1 in 3 chance of getting that correct. If you were entering this into the calculator, which I've shown a video how to do that, or into StatCrunch, you would say that there are 5 trials because there's 5 questions, and the probability of success is 0.333. Or you could just put in the 1/3, that'd be fine also. And then you're interested in what's the chances that I would get 0, 1, 2, 3, 4, and 5. In this particular graph, the random variable p of x is showing the probability of correct answers on the test. So if I delete this square, you can see that the probability of getting 0 questions correct is about 13%. The probability that you'll get 1 correct is about 33%, pretty much the same for 2. But then to get 3 correct, you're about 16%. And then 4 is 4% chance, and 5 is less than 1% chance that you would get those all right if you were just randomly guessing. But the sum of all those probabilities is equal to 1. That's one of the things we look for when we say, is this actually a probability distribution? It has to add up to 1 for us to be able to say that, and notice that all of our individual values are between 0 and 1. And then also just wanted to mention that we can do the graph of a probability distribution. And the graph are similar to histograms, but the vertical scale on a probability distribution has percentages rather than frequencies. So that's the introduction to probability distributions. We'll talk more about others later.